Hello everyone, welcome to Vishesh Educational Videos. In this video, I am explaining one of the classical problems of synchronization, that is bounded buffer problem. Bounded buffer problem is also called as producer-consumer problem. Actually, I explained producer-consumer problem while explaining the inter-process communication and also while explaining the critical section. If you want to know more about those videos, the link for that video is in the description. So if you are not subscribed to my channel, please subscribe to my channel. To get the notification of my new videos, please click the bell icon. So let me begin the explanation of bounded buffer problem. So SEMAPHORE is a solution to a critical section problem. So SEMAPHORE allows the process, only one process, it allows only one process to enter into its critical section and execute. If another process wants to execute in its critical section, it can't, right? Because when a process is executing in its critical section, no other process can enter into its critical section. Only after the old process finishes its execution in its critical section, then only the new process can enter into its critical section. Right? So while explaining producer consumer problem in inter-process communication, I used a variable called count variable, but here in this session, right, to explain the bounded buffer problem, I'm using a SEMAPHORE. I'm not using the count variable. Here the difference you understood, right? So I'm explaining the producer consumer problem using a SEMAPHORE, not using the count variable. Getting, guys? So now you should understand what is a SEMAPHORE. You know that SEMAPHORE is the solution to the critical section problem. So what is a SEMAPHORE here? You can see here a SEMAPHORE is nothing but it's a integer variable. SEMAPHORE is just an integer variable, right? So you have to initialize the SEMAPHORE variable, right? So for example, see here, if your SEMAPHORE variable is initialized, assume that the value is 1 for the SEMAPHORE here, right? And if you want to change the value of that SEMAPHORE, that means if you want to change the value of the SEMAPHORE from 1 to 0, right, you can't do it directly. You can't do it directly, right? So if you want to change the value of the SEMAPHORE, right, you have to use wait and signal. These wait and signal operations are atomic operations, mainly used to, right, change the value of the SEMAPHORE. See here, if you want to change the S value from 1 to 4, you can use a wait operation or a signal operation. How it is? See here. And one more important thing, wait is also called as P, signal is also called as V. You can see here, wait operation, in simple words, it is going to decrement the value of the SEMAPHORE. Signal operation is going to increment the value of the SEMAPHORE. For example, if you want to change the value of S from 1 to 4, you have to increment it. So you have to use wait operation. Suppose if you want to decrement the SEMAPHORE value from 1 to 0, right? So you have to use signal operation. Sorry, yes. So 0 to 1 here, sorry, signal increments, wait decrements, right? Now you know that SEMAPHORE is an integer variable, right? That SEMAPHORE can be accessed by two atomic operations, wait and signal. Atomic operations means no interrupts can stop these operations, wait and signal. So wait is going to decrement the SEMAPHORE value, signal is going to increment the SEMAPHORE value. Now I will explain the bounded buffer problem using a SEMAPHORE, that is producer consumer problem, right, using a SEMAPHORE. You can see here we have a producer and we have a consumer. Both the producer and consumer can access the buffer, right? You can see here we have n buffers. What is the size here? Size is 5. So we have 5 slots in a buffer. Both producer and consumer can use this buffer. Understanding, guys? So buffer, how many slots are there in the buffer? 5 slots are there in the buffer. So here we have n buffers. N is what here? 5. Each buffer can hold one item. You can see there 5 slots is there, right? So each 5 items can be, right, buffer can hold 5 items. Buffer can hold 5 items. Now here, to explain the bounded buffer problem using a semaphore, I am using 3 types of semaphores here, right? One is a mutex semaphore, another one is a full semaphore, and third one is a empty semaphore. So I will explain this each semaphore in detail. See here, mutex semaphore, initial value will be 1. Remember this is very important. Mutex semaphore, initial value will be 1. Here, if mutex is 1 means you should understand that no process is executing in its critical section. If mutex is 0, process is executing in its critical section. Just remember this. Simple. Now, what is a full semaphore? Initially, the full value will be 0. So, full semaphore, what it does? It tells how many buffers are full. Suppose if full is 0 means what? Initially, all the buffers are empty. Right, guys? So, full tells how many buffers are full. If full is 1, that means only 1 slot is full. If full is 5, then 5 slots is full. But what is full is 0? It means initially all the buffers are empty. Just remember that. Now, what is empty semaphore? So, empty semaphore, it tells how many buffers are empty. And the initially empty will be equal to n. What is n here? 5. So, initially empty will be equal to n, that is 5. So that means initially all the 5 slots will be empty. Empty is equal to 5 means all the buffers are empty. So all the buffer slots are empty. Here 5 slots are empty because my n is 5. Getting, guys? So I need to use this mutex semaphore, full semaphore and empty semaphore, right, for a bounded buffer problem, right? Now initially, see here, your producer and consumer will be like this. So producer can access the buffer, right, and consumer can also access the buffer. See here, producer produces an item, producer will produce an item and keep it in the buffer. Consumer will consume the item from the buffer. Very simple logic here. So what is that? Producer will produce the item in the buffer and keeps it in the buffer. Producer will produce the item and keeps it in the buffer. Consumer will consume the item from the buffer. Both can access it, right? So this is very important. Now, so this is the structure of the producer process. It's a very simple code. No complications are here. So I will explain this, right, in the coming slides. This is the structure of the producer process. See here, and this is the structure of the consumer process. I will explain this both the structures in detail, right? This is the structure of the consumer process. Now I will start with the working of the producer. First I will start from the working of the producer. So you can see here, this is the code of the producer here, right, and these are the values of the semaphores, initial values of the semaphores. You can see initial value of the full semaphore is 0, initial value of the mutex is 1, empty is equal to n, that is n is 5. So these are the initial values of the semaphore and this is the code. Now I will explain the working of the producer now. See here. So in the first step we will consider that producer is going to produce an item 10. So here producer is going to produce an item. What is that item? 10. And it's going to, right, use a variable called next p. You can see the item that is produced will be there in the variable next p. So what is the item that is going to be produced? 10 here. 10. Now item is produced. Remember that item is only produced. It is not in the buffer yet. It is not in the buffer yet. It is only produced. Now, so what happens? The next statement. What is the next statement? Wait of empty will be executed. So what is the value of empty? Because here for a producer, it has to check whether my buffer is full or not. Sorry, my buffer, yes, if it is full, it can't produce an item, right? That's why it has to check. For a producer, buffer should not be full. It can't produce. That's why it is checking for empty. See, wait of empty will be executed here. Empty value is 5. That means what? All the 5 buffers are empty. You can see the diagram. All the 5 buffers are empty. Now producer can produce without any problem because all the 5 buffers are empty. But along with checking the empty condition, wait means what? I already told you, wait is going to decrement the value. So wait, now what it will do means it will decrement the value of empty. So what is the value of empty? 5. 5 value will be decremented to 4. Why it is? I will explain. Next you will understand that why the empty value is decremented from 5 to 4. But initially you should know that. So it produced the item. Next it should check whether the buffer is empty or not, because it has to produce that. So it's checked that. So here all the 5 buffers are empty. Now it can produce an item without any problem. But remember, so it decremented the value of empty from 5 to 4. You will understand why it is. Now what is the next step? Wait of mutex. Wait of mutex. You can see here. So this will be the, now this is my structure of the buffer. Nothing is there in the buffer, right? So next statement is what? Next wait of mutex will be executed. Here mutex value is what? Initially mutex value is 1. So mutex value is 1 means what? No process is executing in its critical section. Mutex value, it is checking for the mutex value. Mutex value is 1. So mutex value is 1 means no process is executing in its critical section. So producer can enter into its critical section. Producer can easily enter into its critical section because mutex value is 1. And also along with that, mutex value will be decremented to 0. So mutex value will be decremented to 0. From 1 it becomes 0. You will understand that why empty is decremented and mutex is decremented. Getting, guys? So now producer can easily enter into the critical section. So this is the critical section. It is a producer produced the item, but it is not still added the item into the buffer, right? So it has to enter into the critical section. Now it is entered into its critical section because mutex value is 1. So see, in critical section, producer will add the item 10. It will add the item 10 to what? Buffer. See, it will add the 10 item to buffer. First it produced, next is checked for whether the buffer is empty or not. Next is checked whether the critical section is free or not. Then after the critical section is available, after the slot in the buffer is also available, it added the item 10 into the buffer. So now in the buffer producer produced the item 10, right? So, and remember, producer is still in the critical section. Now next, what is the next statement? Signal of mutex. Now 10 is there. So next, so your buffer will look like this. So first element is there, 10 is there. Now producer will execute signal of mutex. Signal means what? You are going to increment the value. So what is the value of the mutex here? 0, because it's changed to 0 by producer. So before leaving, producer before leaving, what it will do means it will change the mutex value to 1. Why it is doing like this means if a consumer wants to enter into the critical section, consumer can enter easily because value of mutex is now 1, that is changed by the producer. That's why, right? And also before leaving, producer is executing full statement. That is signal of full is executed. Signal means what? You are going to increment. Now value of full. What is the value of full? 0, right? You can see. Now full value will be incremented to 1. The full value will become 1. Why? It means that one slot of the buffer is full because 10 is added, right? Full is now 1. It is changed from 0 to 1. That means one slot of the buffer is used. That's why full value is 1. Full is 5 means all the full 5 slots are used. But here is 1. So only one slot of the buffer is used. So understood? So producer, now it can come out of the critical section. Now, how many items are there in the buffer? One item is there in the buffer. Producer produced the item 10. Now, consumer has to consume it. Now, I will explain the working of the consumer. Suppose if you have any doubts, please post your doubts in the comment section. Right? So, I will explain the working of the consumer here. So, this is the code for the consumer. It is very simple. And these are the values of the semaphores, that is after the execution of the producer. So full is now 1 because producer changed the value of full from 0 to 1. Mutex is 1, producer changed it, and empty is 4. You know that I told you, right? The why the empty value is 4 means I told you, right? Why I decremented the value of for empty to 4 means because 10 is there. Empty is changed from 5 to 4 because already one slot is used. That's why I decremented the empty to 5 to 4. Now you understood, I think, right? So these are the values of the semaphores after the item is produced. Now I will explain the working of the consumer. See here. So this is the structure of the buffer. So consumer will start executing here. One item is there in the buffer. So see, first wait of full is executed. Here consumer should check the buffer should not be empty here. If full is 0, what happens? Full is 0 means no item. So obviously your consumer can't execute here. But fortunately here, what is the full value here? 1 here. 1 means what? That means one slot of the buffer is filled. That means one slot of the buffer is filled. So obviously consumer can continue without any problem. So consumer can proceed and fill will be decremented to 0. Because you know that weight of full. Weight means what? You are going to decrement the value. Consumer can proceed obviously, but along with proceeding, what it will do means it will decrement the value of full to 0. Now value of full is changed from 1 to 0. But consumer will proceed obviously. Next, what is the next statement? Weight of mutex. Next, weight of mutex is executed. Here mutex value is 1. You know that. Producer changed it, right? So mutex while leaving, right? So mutex value is 1. Mutex value is 1 means what? So consumer can enter into its critical section without any problem. Without any problem, consumer can enter into its critical section. But before entering, it will decrement the mutex to 0. Because weight of mutex, it will decrement. So it can enter into its critical section, but before entering, it will decrement the value of mutex to 0. Right? Now, you will understand that why. So next, consumer. So what it will do means, it will remove an item from the buffer. It will remove the item 10 from the buffer and it will store that in the variable next of C. It is removing the item from the buffer. That is, your consumer is executing in its critical section because it is entered into the critical section because mutex is 1. Now consumer is in critical section. In critical section, what it do? It is going to remove the item 10 from the buffer and it is going to store the item consumed to variable next C. So after removing the variable, your buffer structure will be like this. So again buffer will be empty because it removed it, right? So now what is the next statement here? Next statement here, signal of mutex. See, next consumer will execute signal of mutex. So again mutex value will be changed from 0 to 1. Why it is doing this? Consumer before in the critical section, before leaving, it is doing this, right? So it is still in critical section. Why it is doing this means, again it's changing the value, mutex value to 1 means, because producer, if wants to produce one more item next time, it can easily do that, because now mutex value is changed to 1. So that's why producer can easily produce one more item if it wants next time, because mutex value is changed to 1. That's why consumer changed the mutex value to 1. What is the next statement? Signal of empty. Now next, signal of empty will be executed. Empty will be changed to, signal means what? Signal, you know that increment. Signal is nothing but increment. Signal of empty, the empty value will be changed to 5, because see, the item is consumed, the item is removed. That's why again you have to change the empty value from 4 to 5. So empty value will be changed to 5 because item is removed. Now all the 5 slots are available. That's why, so empty value is changed to 5. So it does the changes, consumer does the changes, it removed the item from the buffer. So finally, after removing the item from the buffer and make the changes, so it can consume the item in next C. So finally it consumes the item that is present in the variable next C. Getting, guys? Very simple, right? So it removed it, now it is going to finally consume it after making the changes, because if a producer wants to produce one more item, it can do it without any problems, right? So this is the bounded buffer problem. Here, why it is called as a bounded buffer problem means, you can see my buffer size is limited here. What is my buffer size? My buffer size is limited to 5. That's why this is called as bounded buffer problem. Right, guys? Right? So hope you understood the concept. If you have any doubts, please post your doubts in the comment section. Thank you. Thank you for watching the video.